Okay, so if you consider a region in the xy plane and revolve this region about an axis of revolution, you can generate what's called a solid of revolution. So in this video, we will consider the simplest example of such a solid of revolution, and here's the situation. So imagine that you have here an axis of revolution. So about this axis, you revolve regions in the xy plane. And it's a complete revolution, so you go all around the axis for 360 degrees. Imagine that the region is simply a rectangular region that is 1 perpendicular to the axis of revolution, 2 touches the axis of revolution. So suppose that this is our situation. Now you can imagine as you revolve this rectangle about this axis very rapidly, it will generate a disk. Right? So you can imagine again, this is the axis of revolution going through the center of your disk, and you see as you revolve the rectangle around the axis of revolution, it generates a little disk. So by picking a very simple region in the xy plane, being a rectangular region touching the axis of revolution and being perpendicular to it, would generate a very simple solid of revolution, being a disk. Well, we want the volume of this solid. If you think of it, the volume will be the surface area times the height of our disk, or if you prefer, the thickness. Well, because we have a rectangle being revolved about the axis, of course this will generate a circle. So we need the radius of the circle, but you can clearly see the radius of the circle is the length of the rectangle. So if you can find the length of your rectangle, you have the radius. And so the surface area is pi r squared. But that's just the area. To get the volume, you must do the area times the height, or the thickness of your disk. But you can again clearly see the height of your disk, or the thickness, is simply the width of the rectangle. And if you think that you are in the xy plane, the width of the rectangle is a small change along the y-axis, and in our application we will consider infinitesimal rectangles. So a width shrinking to 0, so we need here a symbol to represent a width along the y-axis shrinking to 0. Of course this is dy, an infinitesimal change along the y direction. So the height, or the thickness of our disk, is dy, and so the volume is the area of the circle, pi r squared, times the thickness of our disk, dy. And that's it. Now try to imagine the same problem if the axis is horizontal. And let's see how this will affect the formula for the volume. So now we consider a horizontal axis of revolution. The rectangle again is positioned perpendicular to the axis, touching the axis of revolution. And once again, you can imagine if you revolve this rectangle about the axis, it will produce a disk, but now standing up. And again, you can see the axis of revolution going through your disk. And the question is the same as before. What is the volume of the disk? Again, it will be the area of the circle times the thickness. Well, again, we need the radius of the circle, But as in the previous case, the radius is simply the length of the rectangle, and the area of the circle is pi r squared. But now we need the thickness, the width of our disk. This is again the width of the rectangle. But now if you notice, having a vertical rectangle, the width is a small change along the x-axis. And again, we will consider infinitesimal rectangles. And so this will be an infinitesimal change along the x-axis. Of course, this is dx. And so now, if we have a vertical rectangle, the thickness is no longer dy, but it is dx. And so the volume is the area of the circle, pi r squared, times the thickness of our disk, dx. And that's it. So when you have a disk, there are only two options. Well, in the one case, the rectangle must be perpendicular to the axis of revolution. It must touch the axis of revolution. And then you see in both cases, you have to find the area of the circle, pi r squared, pi r squared. R is in both cases simply the length of the rectangle, so nothing changes. The only difference with a horizontal rectangle, the thickness of your disk is dy, so the volume is pi r squared dy. For a vertical rectangle, the thickness of your disk is dx, and so the volume is pi r squared dx. And that's it.